Hello, everyone. It's been quite an exciting day. It's been kind of a long day, but we still have some great moments ahead. We have someone very special that would like to share some words with you. He's been here throughout the day, and he's been representing HP, our diamond sponsor. So if you would like to come and join us, please welcome on stage Ramón Pastor.
Thank you. Good afternoon, everyone. Long day, eh? So I'm really thrilled to be here in the first edition of this in 3D industry event. First, I hope of many. Really, this first one has been a huge success. A lot of traffic, a lot of interest, a lot of very good discussions. But I want to start with an observation. No? Observation about this in 3D industry event, about basically these 2-3 days that will be together. And observation really about 3D printing technology, about the concept of Industry 4.0, about why do we think there's going to be a big change on the industry in this 21st century. And the reason behind all of this is digitization. The fact that everything, all the data, all the information can be placed in zero and ones, in the most simple, flexible, optimizable way. And when you basically get this idea of digitization, this concept of having zero and ones, and you basically place this to the last moment of the decision-making processes, the last moment of supply chains, the last moment of the production chain, this is when you can transform industries. In the case of fabrication, in the case of 3D printing, digitization basically plays a very important role. When basically you can carry everything in 3-in-1s to the last moment where you transform bits into atoms, this is where suddenly you have the flexibility to respond to changes in design, the flexibility to respond to changes in forecast, changes of mix. This is when you economically can do personalized products, short runs. This is when you can reproduce all the geometries, giving your designer the freedom to do much more effective designs. Digitization really has transformed many industries, from the generation and transmission of contents, from more traditional industries like transportation. But let me now talk about a very specific industry, the 2D printing industry. This is something that is very near to us, HP. On the 2D printing industry, the same digitization process have had a very profound effect. There's many verticals, signage, photography, where the traditional technologies, silver highlight, screen printing, are almost obsolete because of the new digital printing technologies. If we look for a second what has had the impact of digitization of 2D printing has created, for the last 30 years, a business of around $230 billion, American billions, $230,000 million. From the mid-80s, where the 2D printing technologies were invented, thermal inkjet, laser, today we have this big figure. If you compare with 3D printing, a technology that was invented on the same time frame, stereolithography was invented on the mid-80s also, the evolution has been very, very, very different. It has created a market around $5 billion. 5 to 230, almost 2 orders of magnitude of difference. Why? Why two disruptive technology that could actually transform big markets have had this very different evolution? And if you reflect, if actually I reflect back on why the reason of this different evolution, there is different factors. The first one is riding macro trends. In the case of 2D printing, we rode different macro trends. One important one was the fact of the rise of PCs, of personal computing. This gave people really the power of computing, of processing, the ability to create content. And with these macro trends came applications. It's very important to have a killer application, a killer app, for you really to scale. In case of 2D printing, the first killer app that we had was the creation of word processors. People suddenly could create documents, and they had the need to print them. A third factor, standards. For the oldies, if you remember, when we begin to have PCs, you had, for each of the applications, you had a driver. So basically you need a number of drivers where the number of applications times the number of printers. It was not only until the first standards came, PCL, HPGL, PostScript, PDF, that basically what you see is what you get. This paradigm of what you see on the screen is what you actually see on the output of your printer was achieved. The last factor, actually probably the most important, was the evolution of technology. You cannot pretend that you will disrupt, for instance, the photography market if your output doesn't have photographic quality. So if you reflect back these four factors, macro trends, applications, standards, technology evolution, these are really the four factors that we need to pay attention to project what will be the evolution of 3D printing. And let's start with them. Let's start with the first one. Which are the macro trends that 3D printing will ride on the future? Let's start with the first one. The personalization of products and services. We all, as consumers, have preference, are willing to pay more for personalized products. It's very obvious, and just remember the Coca-Cola campaign last year where actually people were willing to go and drink thousands of bottles of Coca-Cola because they had your name. This is basically the power of personalization. Now, the problem with personalization is that today, the current way of fabrication doesn't allow to economically do personalized products. The reason is because there is a big fixed cost involved on fabrication. You want to fabricate this object, you need to do a mold, which has a certain price, tens of thousands of euros, that you want to do one, basically you amortize this fixed cost into one. Basically, difficult really to do economically a personalized product. And here 3D printing can help. There is no fixed cost involved, as most of you know, and basically the only thing that you have is variable cost, enabling applications like hearing aids that basically fit specifically your ear, or basically these cranial gaskets that basically are used, and it's important basically for them to be personalized. Other macro trends, no? The acceleration of the innovation. There is less and less time between better and better products, which places a lot of pressure on companies like yours, like ours, to really shorten the development cycles. And the way to shorten development cycles is basically to iterate designs through prototypes really, really quickly. Current way of fabrication, again, places you a limit of what you can do. If you want to do a prototype, you need to ask for a proto mold. 4 to 6 weeks later, you get the prototypes, you test them, you iterate, you do a new design. 4 to 6 weeks later, you get, it's a long process. Again, 3D printing here can help by having prototypes in hours or days. Democratization of innovation. The phenomenon of startups. There is more and more capital available to invest in small companies that have disruptive business model, have disruptive technology. However, if you think about this, most of the startups that you all know are software-based. Why? Because software is very scalable. Once you have done your software product, scale it is very cheap. The hardware-based startups need a very, very good financial muscle because it's very expensive to start fabrication. And here is where 3D printing also can help to do this, either bridge production, do the first products, test them on the market, iterate, learn, and when you're sure that you want to scale, when you have sold some units 3D printed, then you maybe can invest on mass production tools. And the startup phenomena is really only the tip of the ice of a broader discussion that we have, which is basically which is the role of the Western economies on the industrial world of the 21st century. It was very clear during the 20th century what was the role, but basically we lost most of our industries through the basically offshoring phenomena. And the reason, again, why we did lose a lot of the industry is because, again, the current paradigm. Big fixed costs that you tend to consolidate in big infrastructures, not being automated, so basically you put them in areas of the world with lower wages, with lower salaries, creating the current manufacturing paradigm. You manufacture in certain areas of the world, and you transport all the products to where the demand is, which is a very inefficient supply chain. Distribution costs, logistic costs, warehouses, scrap, and what is more important, it has an ecological price to pay. A significant part of the petrol of the world, of the fuel of the world, is used to transport goods from where they are produced to where they are consumed. And on here, 3D printing, again, can help to change the paradigm from producing and distributing to distributing the design and manufacture very, very near to where the demand is and only what you need. So you can see really how 3D printing is beginning to be aligned with a lot of the macro trends that we see every day on the world. Let's move to the second factor. What was the second factor? Standards, tools, processes, workflows. For the last 30 years, the protocol of transmission of 3D printing models, of 3D models from the CAD software to the printer was the STL file format. Very primitive, inefficient, not very good language that basically permitted the transmission of broken models, models that were not watertight, models that were wrong for the technology that were repurposed to, models that actually you couldn't specify color, material, post-processing. Fortunately, the core of the industry have came together and have defined a new open standard, the 3MF standard. This year, actually, is the first year that will be public, and you will see some of the printers actually supporting 3MF. One of the first ones is basically the HP printer we are announcing actually today in Europe. Great achievement. Now, let's talk more about solutions of workflows. Really what we're seeing is more and more companies beginning to understand the potential of designing for 3D. The first step really is to start with a part that you have designed for traditional manufacturing. And as you well know, when you design a part for traditional manufacturing, you need to know which will be the method of manufacturing, because each manufacturing method imposes certain geometrical constraints. The beauty of 3D printing is that basically complexity is free. So basically you can do whatever geometry, which means that you can do lighter structures. You can do structures that uses less material, structures that optimizes certain performance. This, what we are projecting here, is just a very, very simple example of one part of one of our large format printers that we designed here in the HP campus. It's on production, and basically what the R&D team did in light of the developments of the 3D printers that we have running in HP is, wow, let's redesign this part thinking on 3D. What they did, they used hollow structures, they basically redesigned the form, they came out with a geometry that today cannot be fabricated, but can be 3D printed. The result is that we have changed the production method of this part, saving 80% of the waste and more than 70% of cost reduction. Now, the power is not when you redesign a part to 3D print. The power where you do design from zero. And this is what the CAD software of next generation will allow us. The constraint-based design, the generative design, next generation softwares will allow a designer, an engineer to specify an object, specify which are the interfaces that they will have. For instance, this part has an interface on the top, interface for another part on the front, and basically you will tell the software, please iterate and find for me which is the best way to actually join these two surfaces to optimize for certain mechanical properties and thermal properties. So the design software will begin to iterate, and find basically a geometry that, one, no designer would be ever think on designing something like this. Second, usually are geometries that today cannot be produced, cannot be fabricated, unless you 3D print. So this is a little bit the world that is coming, the new workflows, the new mindset on how to design to take full advantage of the world of 3D. Next factor, if you remember, no? The evolution of technology. We all have had, at some moment in our career, the illusion of 3D printing is a technology that is, wow, is evolving like crazy. I'm sorry to wake you up. The truth is actually the 3D printing technologies have had very little innovation till now. Very incremental innovation. So basically, what we see today on 3D printing versus what we had 10 years ago is an improvement, but it's not enough to really make this change into production. Now, this year, new technologies are coming into place. One of those are basically the technology that we have invented and developed and productized here in the HP labs, here near to Barcelona, the multi-jet fusion technology. Let me show you a little bit of a glimpse of what this does.
Tapping the potential of the smallest things has always led to giant leaps for humankind. So when we set out to reinvent 3D printing, we began at the molecular level with the smallest of building blocks, the mighty HP voxel, which led us to this, a leap beyond all the current limitations of 3D printing. Meet the HP Jet Fusion 3D printing solution. From this day forward, you will be able to reinvent the way you prototype and manufacture by creating consistently high quality and fully functional parts, up to 10 times faster at the lowest cost. Continuous printing and fast cooling processes allow more production in the same day. From design to part, HP Jet Fusion 3D printing delivers an end-to-end solution that scales with your business. And the HP Multi-Jet Fusion Open Platform gives you access to a wider range of future materials and applications. Start reinventing the way you prototype and manufacture, voxel by voxel. HP Jet Fusion 3D printing. Keep reinventing.
At the end, what you need to disrupt manufacturing are two things, two simple things. First one, industrial grade quality. You cannot disrupt production if the objects that you are 3D printing are not production worthy. The second is economics. You cannot actually penetrate and do short runs, mid runs, or eventually big runs if your running costs are not the ones that you need to run efficiently your company. Very simple, two things. The first one, basically, now we are beginning to have technologies that produce production quality parts. The second, this is more tricky. How do you decide as a customer, as a user, if it's better for you to 3D print a part or it's better for you to cut a mold and actually do injection molding. This is basically by this break-even point type of analysis, where you plot basically the cost per part and basically the run length that you want to manufacture. If you are doing injection molding, for instance, and if you want to do a run length of 1, basically very, very expensive, because you need to do this investment in the mold, and you need to amortize by 1. If you want to do 1 million, much cheaper, because you amortize this fixed investment in 1 million parts, and the variable cost, the marginal cost of a part that injected molding is very, very, very small. In 3D printing, cost is independent on the run length, simplifying. So really where the two curves cut, this is the break-even point. To the right, makes sense to 3D print. To the left, makes sense to cut a mold. So which is the break-even point of technologies today? They're all over the place. The good news is that actually the new generation technologies basically are running much, much cheaper. The break-even points, now we're talking about tens of thousands. Just to put an example, this gear, this part, has a break-even point of 55,000 units. So if you're going to do 50,000 units, much better to do it in 3D printing. If you're going to do 60,000 units, better that you invest in a mold. And the multi-jet fusion technology really is another breakthrough, not only in terms of quality, in terms of speed, but also in terms of cost. And the best proof is that actually to build our own printer, half of the custom plastic parts, we are going to print them with our own printer. This is 66 parts, plastic parts from the printer up there, are printed with our own technology. Going to really this frightening theme of the printer that is printing themselves, no? So let me go to the final factor, applications. Which are the killer apps? And I'm not going to talk about the current application. I mean, this pavilion is really full of really exciting applications. Let me give you a glimpse on the future applications. And the future applications I'm going to talk about are possible because of the fact that the next generation technologies in 3D printing would be able to control the mechanical properties, the thermal properties, the electrical conductivity properties at the voxel level. A voxel, as you very well know, is a pixel in 3 dimensions. In the case of our technology, it's a box of 20 microns by 20 microns by 70 microns. Imagine if your designers, your engineers could decide at every micro voxel what would be the different mechanical properties, thermal properties, electrical conductivity properties. You could actually start thinking of new applications. Applications, for instance, like embedding sensors in all the parts that you do. This is actually a part that we have printed on the stand, which basically, while we were printing them, we are modifying the conductivity of some of the boxes by printing actually a strain gauge. So actually, it transmits real-time the tension that this chain link is having, actually warning the user before actually it's going to break. Imagine the world where, for instance, all the parts from your car, all the parts in the airplane that you are flying had these sensors embedded and were transmitting real-time the deformations, the fatigue. Welcome to the world of Internet of Things. Really the world of Internet of Things. So, wrapping this up, we'll talk about a number of factors that will tell us really the evolution of 3D printing. Before we quantify this, let's go a little bit back. Let's put a little bit of context. At the beginning, before the Industrial Revolution, design was done locally, and production was done locally. Usually, the designer and the producer were the same person. It was the artisan. And they were doing products under demand, personalized. after the two first industrial revolutions, this changed. The concept of mass production gave access to many, many people to objects, make them affordable, at the price of being generic. And did another thing. It disjoined really the role of the designer and the producer. Then came internet and connected the world, and actually did something more profound, which is basically change physically where the designer was and where the producer was, and also changed physically where the production was done and the consumption of the product was done. And right now, we are in a very special moment on the history of industry, where all digitization will have an effect, and probably will have an effect in two phases. The first one is basically making much more efficient all the current workflow that we are used to. Now, the second phase is where this will come into play, where actually digitization, 3D printing, and other technologies will actually rewire the whole ecosystem, moving us to a new paradigm of fabrication, a new paradigm, a new world where on-demand production will replace mass production, where personalized products will replace generic products, where printing locally, manufacturing locally, will replace printing centrally, where the barriers of entry for the new tools of manufacturing will drop. Everybody will become actually a creator and a producer, where the rhythm of innovation will accelerate. This is our vision.
To you, designers and engineers, captains of industry, and leaders of thought, anyone whose ambitions have ever exceeded what was possible, this is your moment, your rewrite history, the world is not flat moment. Every facet of how you design and manufacture is about to be reinvented, and it all starts here. With the smallest of building blocks, the mighty HP Voxel. You and it are about to change the world by advancing radical prototyping, accelerating manufacturing, and taking precision and strength to unheard of heights. From today forward, the 3D printer is a factory for thought, where the things we make will make us smarter, better, more human. What a future we'll create with new materials and embedded intelligence. Together, we'll bring extraordinary to the everyday and reality to dreams light years away. Welcome to the age of digital production, on demand, a world without waste, without inventory, without warehouses. Meet the first HP Jet Fusion 3D printers, the digital furnaces of the next industrial revolution. Join us as we engineer the never-before Voxel by Voxel. HP Multi-Jet Fusion. Keep reinventing.
I want really to end up this keynote with a call to action, and is that we are all in a mission to rewrite the new rules of the 21st century industrial world. A mission to redefine what is the role of Europe in this new industrial revolution. And a mission to make, again, design and production personal again. Thank you.